The cosmos is vast, dark, and mostly empty. Yet, every now and then, it sends us a message in a bottle. A traveler from a distant, unknown shore. On July 1st, 2025, our telescopes caught sight of just such a messenger. Astronomers named it 3I Atlas. This object is not one of ours. It was not born in our solar system alongside Earth, Mars, or Jupiter. It comes from the great darkness between the stars, a true interstellar visitor. It is only the third such object we have ever confirmed in all of human history, a rare and precious gift from the galaxy. It is a whisper from a star system we may never see. What does it mean for an object to be interstellar? Imagine our sun is a house on a quiet street. All the planets, asteroids, and comets that circle our sun live on this street. They are part of our solar family. But an interstellar object is like a tourist from a completely different country, one that has traveled across vast oceans of space to briefly visit our neighborhood. These visitors are incredibly rare because the distances between stars are almost unimaginably huge. To find one is a momentous occasion, a chance to meet a stranger from a faraway land and learn something new about the universe we all share. The discovery of 3I Atlas was a product of both powerful technology and keen human observation. It was first flagged by the Asteroid Terrestrial Impact Last Alert System, or ATLAS, a set of robotic telescopes that constantly scan the night sky for moving objects. But its story was pieced together when an amateur astronomer named Sam Dean looked back through older images. He found faint traces of the object in photos taken days earlier, helping scientists confirm its extraordinary path. This teamwork between automated surveys and passionate skywatchers is a beautiful example of modern science, where anyone with curiosity can contribute to our cosmic story. Scientists at the Minor Planet Center, the official record keepers of the cosmos, studied its trajectory carefully. They looked at how fast it was moving and the shape of its orbit. The verdict was clear. The object was on a path that could not have started within our solar system. Its orbit is what we call highly hyperbolic, meaning it's a wide, open-ended curve, not a closed loop like the paths of our planets. It is here for a short visit. After swinging past our sun, it will continue its journey, heading back out into the interstellar void, never to return. This celestial wanderer is on an incredible journey through our cosmic backyard. 3I Atlas is hurtling through space at a staggering speed of about 66 kilometers per second. That's over 147,000 miles per hour. It's moving so fast that our sun's gravity is not strong enough to capture it and pull it into a permanent orbit. Instead, our star will act like a gravitational slingshot, bending its path and flinging it back out into the galaxy. The object is currently racing towards the inner solar system, giving us a front-row seat to its spectacular, fleeting passage through our neighborhood. Its path has been precisely calculated, so we know exactly where it is going. It is coming from the direction of the Milky Way's thin disk, the flat plane where most of our galaxy's stars reside. On October 27, 2025, it will make its closest approach to the Sun, an event astronomers call perihelion, coming within about 1.4 astronomical units. 1 astronomical unit is the distance from the Earth to the Sun, so this is still quite far away. It will also make a flyby of Mars around the same time. This carefully mapped trajectory allows telescopes around the world to prepare for its arrival. The most important question for many is it a danger to us? The answer is a resounding no. Scientists, including the European Space Agency's head of planetary defense, have confirmed that 3I Atlas poses zero threat to Earth. Its closest approach to our planet will occur on December 17, 2025, but it will remain at a very safe distance of 2.4 astronomical units. That is more than 220 million miles away from us, far beyond the orbit of Mars. We can observe this visitor with curiosity and wonder, free from any fear. It is a guest, not an invader, here to teach us, not to harm us. After its closest encounters with the Sun and Earth, the object's journey is far from over. Its path will carry it out towards the gas giants. In March of 2026, it will pass by the mighty planet Jupiter, its course slightly altered by the giant's immense gravity. From there, it will continue its outbound voyage, slowly fading from our view as it recedes into the darkness. By April 2026, its speed relative to Earth will increase to a blistering 90 kilometers per second. It will become a faint memory in our telescopes, but the data it leaves behind will be studied for years to come. What is this mysterious object actually like? All signs point to 3I Atlas being a comet, but a truly enormous one. Early observations show that it has a fuzzy atmosphere, or coma, and even a short tail. This happens when an icy body gets closer to the sun and the solar radiation heats its surface, causing ice to turn directly into gas and release dust. This cometary activity is what makes it glow, and its brightness suggests that 3I Atlas could be a giant. Its core or nucleus might be up to 12 miles or 20 kilometers across, making it a true behemoth. To understand how special 3I Atlas is, we can compare it to its two predecessors. The first interstellar visitor, discovered in 2017, was named Oumuamua. It was a bizarre, cigar-shaped enigma. It was small, rocky, and showed no signs of a cometary coma, yet it accelerated away from the sun, as if something were pushing it. Its true nature remains one of astronomy's most tantalizing mysteries. Oumuamua was a strange puzzle, unlike anything we had ever seen before, leaving us with more questions than answers about what kind of objects wander between the stars. The second visitor, 2I Borisov, arrived in 2019. It was much more familiar to us. Borisov was clearly an interstellar comet, complete with a fuzzy coma and a long tail. It looked and behaved much like the comets from our own solar system, just visiting from another star. It was a crucial discovery, proving that comets like our own exist in other planetary systems. At about half a mile wide, Borisov was a fascinating specimen, but 3I Atlas appears to dwarf it. If its size is confirmed, 3I Atlas would be the undisputed king of interstellar comets discovered so far. The immense size of 3I Atlas is what truly sets it apart and gets scientists so excited. A larger object means there is more material for us to study. Its bright, sprawling coma gives off light that can be analyzed to determine its chemical composition. Are the ices on this comet made of the same water, carbon monoxide, and other molecules found in our own comets? Or does it contain exotic ingredients that hint at a different kind of chemistry in its home star system? A bigger, brighter object makes it easier for our instruments to capture this light and decode the secrets hidden within. The discovery of 3I Atlas is more than just a cosmic curiosity, it is a golden opportunity for science. This object is a pristine sample of a building block from another solar system, delivered right to our doorstep. Studying it is like being an archaeologist who has just been handed a perfectly preserved artifact from a lost civilization. By analyzing its light, we can learn about the chemical environment around the star where it was born. This information can tell us if other solar systems have the same raw ingredients for life that ours did, a profound question in our search for our place in the universe. Observatories around the world and in space are turning their powerful eyes toward this ghostly visitor. The James Webb Space Telescope, with its incredible sensitivity, will be a key player. It can detect the faint infrared glow from the molecules in the comet's coma, providing a detailed chemical fingerprint. Ground-based telescopes will track its movement with exquisite precision, looking for any tiny deviations from its predicted path. Such deviations, like those seen with Oumuamua, could hint at forces other than gravity at play, revealing more about the object's structure and how it releases gas. Every piece of data we collect adds to a growing library of knowledge about interstellar objects. With only two previous examples, our understanding is very limited. Oumuamua was strange and rocky, while Borisov was a familiar-looking comet. 3I Atlas now provides a third crucial data point. Is it more like Borisov, suggesting that most interstellar travelers are comets? Or does it have unique properties that challenge our assumptions once again? Building this catalogue helps us understand the diversity of objects that are ejected from young solar systems and wander the galaxy for millions of years. As we stand on our tiny planet and look out into the void, we are reminded that we are part of a much larger cosmic community. Objects like 3I Atlas are emissaries, connecting our solar system to the countless others that populate the Milky Way. They prove that the materials that formed our world are not unique. These silent travelers bridge the immense gaps between the stars, carrying stories of their origins. By studying them, we learn not just about their distant homes, but about the universal processes that shape galaxies and ultimately create the potential for worlds like our own.